morning to Dr. Rezar. We are from Group 9 and our topic is liquid chromatography and purification of quality protein. Our group member is me, Adeline Emira 74646, Chan Yong-sun 74378, Richard Wong 76631, Nor Farediba 76071, and Gabriel 74883.
Fast protein liquid chromatography is used to decontaminate essential protein. This study focuses on the implementations of fast protein liquid chromatography to elucidate on complex polypeptides, linkage, uncoiling, complex polypeptides isolations inside urinary waste and cerebrospinal fluid and beta thalassemia evaluation. Other than that, the benefits and the downsides of Fplc are mentioned in this study report. The theoretical operational principles for Fplc alongside its label diagrams are elucidated in the subsequent explanation. Fplc is influenced by chromatography type implementations during the testing, as the techniques for the process are elucidated in methodology section. Through examinations of the findings from this testing, Fplc implemented with gel refinement is employed for the actin's isolation from a solution of myofibrillar complex polypeptides. The findings also depict that actin becomes an obvious peak, succeeding the gel refinement implementations in the mixture during the testing. Protein mixture troponin, actin, alpha-actinin, and myosins are eluted in two discrete maxima. Meanwhile, the trombomyosin seems to form the shoulder for the actin peak. However, the isolation for actin's molecular mass region is barely successful due to the presence of trombomyosin and alpha-actinin within actin that contains fragments, which could possibly interrupt the numerical approximation for the actin when peak area measurement is implemented.
Okay. Regarding the introduction of fast protein liquid chromatography (FPLC), it is one of the liquid chromatographic methods utilized for decontaminating macromolecules from proteins. This technology has a large loading capacity, high flow rates, biocompatible buffer systems, and stationary phases for typical chromatography methods such as gel filtration, ion exchange, reverse phase, and affinity chromatography. High precision pumps, control units, coulomb, detector, and fraction collector are all the components of the Fplc system. It is widely utilized in various applications such as the evaluation of protein unfolding, plasma protein separation in urine and cerebrospinal fluid, and beta thalassemia diagnosis. Okay. The advantages of Fplc method include simple and reproducible separation method with high resolution, longer lifespan of chromatography coulombs, and supporting a variety of coulombs, and ideal method for analytical and preparative chromatography. On the other hand, this method provides some limitations. For instance, the glass coulomb is often required, and it also cannot resist high pressures when the purification of protein is carried out, and high performance liquid chromatography HPLC coulombs are not supported, and it is tough to carry out the purification of heat sensitive protein.
According to SlopeMed 2021, Fplc is used for purifications of quality protein. There are 4 methods used in Fplc, which are SAS exclusion chromatography (SEC), affinity chromatography (AC), ion exchange chromatography (IEX), and hydrophobic interactions (HIC). SEC is a method that is used for separating proteins according to their size. The size of the pores must be larger than the protein so that it can pass through the pores. Thus, the larger protein liquid must enter first, followed by the smallest one. The SEC method is conducted with specific techniques such as gel filtration chromatography (GFC). The SEC method is utilized for separating the proteins at low pressure. Next, acid techniques is also utilized to separate or purify proteins. It is dependent on the greatly precise binding of the analyte to its equivalent. The affinity column is where the equivalent of the analyte is absorbed on the stationary phase. In the process, only the specific analyte can enter the system. Meanwhile, the other substances will be prevented from entering the system. After that, the analyte will be eluted as sharp strip as it can be separated from its equivalent using eluent. The last one is IEX. IEX is also the same as the SEC method, but it is used to separate the electrolytes. IEX method will separate the weak electrolyte from the strong acid. The incorporated acid will then be included at the inside of the resin. The acidic fluid that is used to elute the acid will be used to keep the balance of the pH levels of the substances or molecules.
To keep the flow rate of solvents consistent in Fplc, a microprocessor via a software program is used to control solvent speed. Aqueous buffer is used as mobile phase. Positive displacement pump provides a consistent flow rate, whereas permitting the buffer constituent to be altered by extracting fluids from exterior storage. Beads, normally cross-linked agarose, are put into a cylinder-shaped column to serve a stationary phase. The eluent is flowing across the detector, which determines salt content via conductivity and concentrations of protein via UV light absorption at a wavelength of 280 nanometer. Based on the figure, shows the purification of quality protein using Fplc involves several equipment such as the system pumps, UV detector, sample inject valve, conductivity detector, pH monitor, fraction collector, and waste. The Fplc must be carried out at extremely low pressure because protein can only be purified at low pressure and saline cradles can only be used to avoid corrosion in the equipment used.
Next, I will explain the methodology part. So, the fast protein liquid chromatography (FPLC) method depends on the type of chromatography that is performed. The key procedure will remain the same even though the type of chromatography is different. So, as we can see from the figure on the screen, we have two buffers. So, firstly, the solvent, which is buffer A, flow rate must be maintained constant in fast protein liquid chromatography. Therefore, pumps that transport solvent to the mixer configure and regulate it. In mixer, the buffer utilized are mixed in the procedure and a unique solution with variable buffer concentration is eluted. It is depend on the process stage with buffer B concentration increasing from 0% to 100%. Third, sample is injected via the injection valve and flowing solvent from the mixture transport it to the column. Next, the separation occurs in the sample mixture as various components adhere to or diffuse into the stationary column. The next step is the flow rate. Push the buffer down to the column base, as we can see in the figure on the screen. The sample, on the other hand, is broken down into distinct parts. This is accomplished by separating the components according to their solubility, size, charge, and affinity. The conductivity, which is the salt content, pH, and also the UV absorbance, which is the protein concentration of the eluted solution, are detected on the UV monitor. And lastly, the fraction collector gathers the eluted sample while the recorder displays the result.
Next, it is result and discussion. Table 1 illustrates judgment of peak resolution by varying the conditions of the Fplc gel filtration of standard protein. As you can see from Table 1, the elation of standard proteins is significantly faster when it is below 0.01 mole per liter of phosphate, leading to lower resolution. Peak resolution improves when SDS concentration is reduced from 2% to 0.05%. However, the improvements vanish below 0.1% of SDS. Next, we have Table 2 illustrates the elation volumes in ml of standard proteins by different lengths in cm of the TSK G4000 SW column. As observed from Table 2, peak resolution improves as the column length increases. So, since the optimal separation conditions were established later, the elation volume of standard proteins for 90 cm long of column are not employed for calibration in future research.
And next, Figure 3 illustrates Fplc elation pattern of a commercially obtainable actin 0.99 mg per milliliters with elation volume of 25.4 milliliters. The major constituent actin has an apparent peak in this sample. DTE from protein extraction fluid accounts for high peak near the end of the run. Adjacent to the maximum point of the actin, it is visible that the impurities bring minimal impacts to the adsorbents. Numerous different myofibrillar proteins are most likely the source of the impurities found in commercial actin sample. Figure 4 illustrates the Fplc gel filtration pattern of a mixture 100 microliters of actin and other important myofibrillar proteins. Separate Fplc runs of the myofibrillar proteins are used to determine the elation volumes of troponin, tropomyosin, myosin, alpha-adenine, and actin. Troponin, actin, alpha-adenine, and myosin are elated as discrete maxima after gel filtration of mixture, with tropomyosin appearing like a shoulder of the actin peak. Troponin and alpha-adenine are the contaminants found in actin sample. A clear separation of the actin and myosin is shown in this figure 4, and there is also an effective separation of actin and troponin. However, the molecular mass area of actin shows a less effective separation, and it is reasonable to assume that tropomyosin and alpha-adenine are present in the actin containing fraction, and this circumstance might interfere with quantitative estimation of actin using peak area measurements. Since free mehis has a particular content of 1 mole per mole of actin, free mehis determination ought to be able to measure actin content in the fraction. And actin must be entirely segregated from other free mehis containing myofibrillar protein myosin, which can range from 0 to 2 mole per mole of myosin.
My name is Gabriel Rentap Anatuba with metric number 74883. I will be presenting the conclusion for this study report. Now, in this study report, FPLC's benefits are refinement simplicity, chromatography columns longevity, columns type versatility, and analytical and preliminary suitability, while the limits are usage of a lot of glass columns and intolerance to high pressure, HPLC columns, and temperature-sensitive protein. In this report, we also found out that FPLC is used in protein unfolding, beta thalassemia diagnosis, and plasma protein separation in urine and cerebrospinal fluid. FPLC consists of pump, UV detector, sample injector, valves, pH monitor, and waste. FPLC's main methods are SEC, AC, IEX, and HIC, which you could find in the previous slides. Now for the methodology, the main thing you need to know is that the liquid chromatography dictates the FPLC method, but the main steps are kept constant. First, buffer's flow rate is maintained and pumped to mixer to be monitored. Secondly, buffers are mixed, producing eluted variable buffer solution in correlation to buffer B, concentration that goes from 0 to 100%. Thirdly, sample injection via injection valve then will be transported via solvent to mixer and then to column. Fourthly, sample mixture separation into smaller components filtered into column static phase. Fifthly, buffers got transferred into columns base via flow rate push. And then the sample breakdowns into different pieces via component separation based on solubility, size, charge, and affinity. Sixthly, UV monitor detects salt content and UV absorbance. UV absorbance means the protein concentration in the eluted solution. Lastly, eluted samples are gathered by fragments collector and recorder displays the result. Now from this study, we also know that FPLC used with GFC functions to isolate actin from myofibrillar proteins mixture. Actin is obvious peak correlated to the highest point for actin. Clearly, the contaminants minutely affect the absorbance. Now, multiple myofibrillar proteins are factor for the presence of contaminants in actin mixtures. Gel refinement for the mixture, then elution of troponin, actin, alpha-actin, and myosin produce discrete maxima. Tropomyosin's curve looks like a shoulder to the actin peak. Troponin and alpha-actin are identified in actin mixture. The isolation of actin from impurities, myosin and troponin, which are the impurities, are successful. Now, speculatively, tropomyosin and alpha-actin existence in fraction containing actin is possible. So this might affect the numerical result in validity when peak area measurement is used.